Hey guys, so today we're going to be talking about compound events and probabilities of these. So first off, what is a compound event? So a compound event consists of two or more events that are linked by the words and or the word or. Now, when finding the probability of compound events, we're first going to look at the probability of or events. So to figure out these probabilities, we have a couple concepts we have to understand. First, we need to know what mutually exclusive events are. And mutually exclusive events are two events that have no common outcomes. Means they cannot happen at the same time. Another way to think about it is that the probability of A and B happening, that both of these events happen, is 0, because they can't happen at the same time. So, for example, the probability on my number cube that I roll a 2 and I roll a 3. Like, I can't roll a 2 and a 3 at the same time. Or you can't be in Miss Cooper's second period math class and in Miss Brown's second period Spanish class. Okay, they can't happen at the same time. Now, overlapping events have at least one outcome in common. This means that they can happen at the same time. So, for example, you could be in Miss Cooper's class, or have Miss Cooper as a teacher, and have Miss Brown as a teacher. So you'll need to determine whether they're mutually exclusive or overlapping before we find the probability of two events linked with the word or. So the probability of A or B. So I'm going to kind of title this. This would be how we find the probability of A or B. So if these two events are mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B. Now, if they are overlapping events, that means they have some outcomes in common. The probability of A or B would be the probability of A plus the probability of B minus the probability of A and B. So what's happening here, the reason we don't have it on our mutually exclusive, this minus the probability of A and B, is that, remember, mutually exclusive events, probability of A and B happening is 0. So we're like subtracting 0, so that's why we don't have to really think about it. Now what's happening here, why we have to subtract this probability, is that we're already counting the people in A and the people in B. So what's happening, if they're both of them, we're counting them twice. So we're going to subtract those people that we're counting twice, so we only count them once. Now, another way that you could see this written is the probability of A union B, which is basically the same thing as or, is the probability of A plus the probability of B minus the probability of A intersection B. So this U means union, basically means we're putting them together. And the N means intersection. We're predominantly going to be using the A or B with the words written out. But if you ever take any other type of stats class, they may use this notation. All right, so let's look at problem 1. Suppose you spin a spinner that has 20 equally sized sections numbered from 1 to 20. First, A, what is the probability you spin a 2 or a 5? And B, what is the probability you spin a number that is a multiple of 2 or 5? So I'm going to go to a blank slide so you guys can work this out in the area around. So first off, I'm going to list off, instead of drawing a spinner with 20 sections, I'm just going to list off 20 numbers from 1 to 20. So for A, we are finding the probability that it lands on a 2 or a 5. Now these are mutually exclusive. I can't land on 2 and 5 at the same time. So the probability that it lands on a 2 plus the probability that we land on 5. Well, the probability that we land on 2, there's only one 2, so this is 1 out of 20, plus the probability that we land on a 5, well, there's only one 5, this is plus 1 out of 20. So we get 2 out of 20, which will reduce to 1/10. So the probability that we land on a 2 or a 5 is 1/10. Now part B wanted us to find the probability that we land on a multiple of 2 or a multiple of 5. Now here, these are overlapping events because there's numbers that are multiples of 2 and multiples of 5. So I'm going to find the probability that it's a multiple of 2 plus the probability that it is a multiple of 5 minus the probability that it is a multiple of 2 and 5. So let's find our multiples of 2. So that'd be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this would be 10 out of the 20 plus our multiples of 5. So 5, 10, 15, and 20. So this would be plus 4 out of 20. Minus ones that are multiples of both. This would be minus 2 out of 20 because both 10 and 20 are multiples of both 2 and 5. So 10 plus 4 minus 2 is 12 out of 20, which will reduce to 3/5. All right, so what I'd like you to do now is pause the video and try the U-try here. Pause the video and try the U-try. You'll need to identify if they're overlapping or mutually exclusive. All right, go ahead and check your answers. So A was overlapping events, so we did the probability that it's even, plus the probability that it's less than 4, minus the probability that it is even and less than 4. So 3/6 plus 3/6 minus 1/6, which is 5/6. And then the probability that it is 2 or odd. These are mutually exclusive. They can't happen at the same time. So the probability it's 2 plus the probability that it's odd is 4/6, which would reduce to 2/3. So now we're going to switch gears a little bit and start talking about probability linked with the word and instead of the word or. So first, kind of like how we had to determine if they were mutually exclusive or overlapping, we have to now determine if two events are independent or not independent. So first, independent. And independent events means that the occurrence of one event does not affect the probability of a second event. So this would be something like if you think about like the probability of babies. So 50% chance it's a boy, 50% chance it's a girl. Now say you have a boy first. That does not mean the second time that somebody has a baby, girl is more likely. It's still a 50-50 chance for a boy or girl. Okay, those would be independent events. The probability of having one gender first does not change the probability of having another gender second. Now, if we determine that these events are independent, then we can find the probability of A and B happening at the same time, or excuse me, A and B happening would be the probability of A times the probability of B. So let's look at problem 2. Suppose you roll a red number cube and a blue number cube. What is the probability that you will roll a 3 on the red cube and an even on the blue cube? So we have to think, are these events independent? These two events are independent because rolling one cube does not affect the outcome of rolling another cube. So the probability on the red cube, we're going to find the probability that we roll a red 3 times the probability that we roll a even blue. The probability that we roll a 3 on the red one is 1 out of 6, times the probability that we roll an even on the blue, which would be 3 out of 6. You could reduce this to 1/2, which would give us 3 out of 36, or 1/12. So there's a 1 in 12 chance that we roll a red 3 and an even blue when we roll two number cubes. So go ahead and pause the video and try the U-try. Pause the video and try the U-try. So check your answers. You should have gotten 1/18. Probability that we roll a red 5 is 1/6. The probability that we roll a 1 or a 2 on the blue is 2 out of 6. When we multiply those together, we get 2 out of 36, which would reduce to 1/18. All right, problem 3. We choose a tile from random at the game tiles shown. We replace the first tile and choose again. What is the probability that you choose a dotted and then a dragon? So the big thing about here is that we are replacing these. So since we're replacing, that means they are independent. So the first, the probability that we choose a dotted and then a dragon. So this will be the probability that we choose a dotted times the probability that we choose a dragon. So the probability that we choose a dotted, there are 1, 2, 3, 4 dotted. So this would be 4 out of 15. Times the probability that we choose a dragon, which would be 1, 2, 3 out of 15. Which would give us 12 out of 225, which would reduce to 4 out of 75. All right, so go ahead and pause and try the U-try. All right, check your answers. So the probability that we choose a bird is 2 out of 15, times the probability that we choose a flower, which is 1 out of 15, is 2 out of 225, which will not reduce. So now let's look at dependent events, which would be the opposite of independent. So dependent events are, or two events are dependent if the occurrence of one event affects the probability of the second event. So for example, if we go back to our previous problem, if we do not replace, or without replacement, this changes our values for our subsequent probabilities. So we still do the same math when we find the probability of two dependent events. So the probability of A and B. However, we're going to have the probability of A times the probability of B after A. And this B after A is what changes, okay, because it's no longer equal to the probability of B. So problem 4, same problem, but now this is without replacing. So without replacing the first tile. So the probability that we choose a dotted tile and then a dragon tile. So the probability that we choose a dotted times the probability that we choose a dragon after we've chosen the dotted. So here we have 4 dotted out of the 15. Now I'm going to choose a dotted and I'm not going to put it back in. So this dotted is no longer part of the equation. Now, the probability that I choose a dragon, well, I still have 3 dragons, but now I only have 14 because I took one away. So when we multiply these, we get 12 over 210, which would reduce to 2 out of 35. Sometimes I find it easier to reduce first and then multiply, but either way is fine. All right, go ahead and try the U-try. So pause the video and try the U-try problem. All right, check your answer. You should get 1 out of 105. So the probability that we choose a flower is 1 out of 15, times the probability that we choose a bird without replacing. There's 2 birds, but now only 14 tiles. So this will give us 2 out of 210, which would reduce to 1 out of 105. So problem 5, 1 freshman, 2 sophomores, 4 juniors, and 5 seniors receive top scores in an essay contest. They will choose 2 students to read their essay. 2 names are chosen at random from a hat. What's the probability of a junior and then a senior being chosen. So the probability that we choose a junior, well, there are 4 juniors out of a total 1 plus 2 plus 4 plus 5 is 12. So there's a 4 out of 12 chance that they choose a junior. And then they're going to choose a senior. So, and we're going to multiply. A senior. Now we have 5 seniors, but we've already chosen 1 junior, so now we only have 11 people here. 11 people left to choose from. So this would give us 20 over 132, which would reduce to 5 over 33. All right, go ahead and pause and try the U-try. All right, go ahead and check your answer. You should notice that we're getting the exact same answer here, 5 over 33. So it didn't matter which one we chose first, so the order didn't really matter here. As long as we're choosing the same, we'll have the same outcome in the end. All right, so that's it for today.